I'm going to just talk a little bit about what's new in Parkinson's disease and just divide it into new understandings, new tests, and new treatments. And then I'm going to talk about the year in review for the Pacific Parkinson's Research Center. We've actually had a very exciting and successful year that we would like to share with you. So there has been more insight into the relationship between the immune system and Parkinson's. So this was something that was proposed at UBC many years ago, and it keeps coming back. And so there may be more to this idea of the role of inflammation in Parkinson's and other neurodegenerative diseases. So this will be followed closely. Again, we're going to hear more and more about the genetics of Parkinson's. They've done now a large meta-analysis of more than 425,000 people. There's now close to 30 genetic variants. Maybe Professor Farr can update that number. But we're really moving towards this area of so-called precision medicine, where your actual therapies could be targeted towards people, can be targeted based on your genetic makeup. And this is already starting to happen. And again, I will leave that to Professor Farr to expand on. Again, as I said, I'm the exception, but other than falling off a bicycle in spin class, exercise is generally good for you. And the more we hear about it in Parkinson's, the better it gets. So again, another further study, further cementing the positive results of exercise in Parkinson's. The other area that is becoming very hot is this whole idea of the gut-brain axis and the important role that the gut plays in hosting a number of microbes that then interact with the body that influence the brain. And again, you will hear more about this from Dr. Cresswell and Professor Dudet, but this seems to be a very active area. What about new tests? There have been some studies now across the world looking at whether or not we can do a blood test for Parkinson's. So a small study done in Australia seemed to be promising. A much larger study that was done in Sweden and England, where they were looking at something called neurofilament light chain, and perhaps Dr. Stossel might be talking about whether or not we have that capacity here or will have it at the Center for Brain Health. And so this is something that we should be looking at in the future. The Michael J. Fox Foundation has funded a study to look at breath prints. So whenever you breathe, you actually exude some volatile or organic compounds, and the question is whether or not there may be trace amounts in some of these compounds that could be used for diagnostic purposes. So that's an interesting thing. Man's oldest friend, whether or not, there have been lots of studies where dogs can sniff out types of cancer and so on. And there's a study now being underway as to whether or not there may be subtle changes in the sweat that could be detected by olfaction from a dog. There's been other things that are looking at eye movements, and this is something I'll talk a little bit more, but subtle changes in eye movements. We often look at eye movements clinically to distinguish Parkinson's from some of the Parkinson's-related conditions, but it looks like there may be subtle changes in eye movements that may signal an early onset or changes in the disease early on. Now, what about new treatments? Well, one of the biggest things has just been the new delivery methods of existing drugs. Now, there was a lot of press around finally the BC government approving for select people the use of duodopa, and this is not in the least due to a very successful campaign by the Parkinson's Society of BC, and I see Jean Blake at the back. So a very successful campaign to get that funded. We've done a number of people here. For the right people, it can truly be game-changing. And in fact, one of the pleasant surprises of this is that before people get this therapy, they're so used to having such a short time of their day where they're functional that when they get the therapy and they can do all the things they couldn't do before, they almost overdo it in the first day because they said, oh, this is the first time I've been able to go for a long walk and so on. So it can be a real game changer for the appropriately selected people. So that has been big news that we've implemented that here in this center. There's been other groups that have tried to give apomorphine, which is an injectable drug, subcutaneously. It's not yet approved in Canada, but it's currently being investigated. People have looked at a sublingual form of apomorphine, although unfortunately the FDA did not approve filing for an inhaled levodopa. So these are all medications that are essentially already out there, but looking for novel ways to deliver them. One of the biggest things now appears to be looking at drugs that have been originally designed for something else. And the good thing about that is they've already been proven to be safe because they've been gone through rigorous testing and so on. And so an example of this is exenatide, which is a drug that's used for diabetes. And there are similar drugs that are used for diabetes, and apparently this one is not necessarily the best for diabetes, but it was found almost by accident that in a small study it seems to work very well for Parkinson's. And so this is currently being investigated. Another drug that caused a lot of furor initially was an anti-cancer medication, which was found to be helpful in a small group of people, and this is currently being explored. There is a new drug that's been approved in the US, safinamide, and it's being brought to market here in Canada. It's what's called an MAO-B inhibitor, but already we have a couple of them already, so it's unclear how much additional benefit we will get from that. However, a large study that was looking at creatine, they took the data from that trial, which had to be stopped because unfortunately the creatine didn't help. But when they analyzed the people on MAO and B inhibitors, it seemed to suggest that there is further evidence that they may slow the progression of the disease. There are a number of drugs being developed that target the non-motor symptoms of Parkinson's. So for example, for psychosis, pimavanserin has been approved, and we are desperately looking for this medication to become approved in Canada because it will be very much better than what we currently have available for psychosis associated with Parkinson's. There's new medication looking at for anxiety, for constipation, and for changing the sleep-wake cycles, as we know that sleep is often disrupted in Parkinson's. What about treatments on the horizon? There's a number of groups that are looking at gene therapy, and there's been some preliminary success in that regard. This is something, again, that's also made a lot of press, MRI-focused ultrasound. It's usually used for a condition known as essential tremor, but it can be used for dyskinesias. It's available in Toronto, Calgary, but not yet in BC. And so this is something that we're eagerly looking at. There have been a lot of interest in the development of monoclonal antibodies, and there have been some phase 1 and phase 1B studies that have been investigating the safety and the benefits of this therapy, and vaccines. So these are all things that are currently underway, currently being investigated, but not quite ready for prime time. The other thing that I would like to mention is there's now a lot of interest in new healthcare models. So we do know that we are starting to collect more and more information from people, and we have to do that safely in a secure manner. But we also want to make sure we use that information fruitfully to enhance people's care. So here's a group from the Netherlands that is looking at molecular analysis and brain imaging and wearable devices and so on, and looking at the analysis methods to sort of combine this meaningfully. We think this is the way to go ultimately, and it's good to see that other groups around the world are thinking in a similar fashion. So what about the year? As I said, we've had quite a successful year. The annual meeting of the Movement Disorder Society, which is the premier meeting in the world, was actually held in Vancouver this year. Dr. Stossel was very prominent in the local organization of that, and you can see him being interviewed by Professor Lang from Toronto. And then a number of us, including Dr. Cresswell and a number of the fellows who were in the room, also participated in this, and it was a very successful meeting. We've got a number of awards. Probably the biggest award you'll hear about is from Professor Sosi. where we've been awarded a large grant for the development of, or the installation of a PET MRI scanner, which will be housed literally across the hall. And we'll hear a little bit more about that from Dr. Sosi. And as we heard, one of the most important role of the center is the training of new and upcoming investigators. And so a number of our students got awards. Matt Cicelli, a student of Dr. Stossel, had his work highlighted in the big meeting that was held in Vancouver. Sujin Lee also was awarded a prize for her work related to Parkinson's disease that was funded from a generous gift from the Watershed Foundation. Stephanie Tran also received an award, which is again funded very generously through the Watershed Foundation. And last week, it even resulted in her graduating. So we're going to try and keep her around a bit to do a bit more work, but anyway. So as I mentioned last year, I think, our vision is that ultimately, of course, we want a cure, and we acknowledge that getting to a cure might be very complicated in ways that we can't currently foresee. But I think in the future, we need to think of research that impacts people in the short term, the medium term, and in the long term. And so I think today you'll hear that we have a fairly balanced portfolio in each of these, and I'll touch briefly on some of them. So what are things that we can look at immediately that will have impact on people immediately? Well, one of the things is exercise, and again, we will hear more from Dr. Stossel on the role exercise plays in some of the brain changes. I can tell you that we have also looked at some of the MRI changes that we see as a result of exercise. And so, that there seems to be a number of changes that occur in the brain after exercise. The other thing that I think is important mentioning is there does seem to be a trend, not just in neurology, but in healthcare in general. And that is that traditionally, when we do tests to learn something about a disease, we tend to use big fancy machines like MRI machines or PET machines and so on. And really, what are these, what is this type of research? Well, this research tends to be lab-based. It tends to be expensive, unfortunately. We can only do a few subjects. We can only assess people intermittently. We can only bring someone in to scan them, every few months or so. And unfortunately, it can be a little bit boring for people who have to sort of lie in a scanner for prolonged periods of time. But the big thing is the data tend to be very high quality. So this has been sort of the traditional model: expensive, few data points, but high quality. In contrast, I think where the field is kind of leaning towards is kind of the opposite. So instead of measuring people in big urban centers, we're going to be assessing people in their home. Instead of using fancy capital intensive machines, we'll be using inexpensive sensors to monitor people. Instead of a couple of subjects, we'll be doing thousands and thousands of subjects across the country and pooling the data. And instead of assessing people only once every few months, we're going to try and assess people continuously. And we hope that we can do things that are engaging to people. So if we can take some of our assessment tools and package them up as exciting games that people are happy to play, then that might be useful. The downside of all this is the data tend to be of low quality. And so it means that some of the electrodes fall off, or someone falls asleep, or they wash their hands, and it disrupts the sensors and so on. So there has to be a lot of effort into going through the data and squeezing out what's meaningful. So this is the type of thing that we are looking at: is ways to kind of monitor people, how to safely upload their data into the cloud so that can be done securely and ensuring people's privacy, how all of that can be summarized, and how all that can be data mined later for learning about the disease. The other thing that's very important is in Parkinson's, we also need to know when people take the medicine. So if we need to know how well people are doing throughout the day, we also need to know when they actually took their pills. So this whole idea of smart pill monitors and so on is something that we're looking at. So an ideal situation for us would be when someone comes to the clinic, they've already filled an online screen that we are currently doing with paper. So that might screen for example, depression or cognitive issues. Ideally, the people would be stratified based on their genetic makeup or their imaging. For example, their imaging may suggest, oh, this person's at risk for falling, so we need to especially talk about that. And ideally, this is what would be the holy grail for clinicians. Instead of having to ask you, what time of day are you feeling at your best, that this would be generated automatically as kind of over a 6-month average, where the vertical red lines there are when people actually take their medication. So we can see the relationship between people's performance and their medication. And then some of the testing that we do where we get people to tap their fingers and so on, a lot of this could be automated now. And we think that this will streamline and improve efficiency. And then this will allow the clinician to come up with a more reasoned, optimal decision strategy. And then ideally when people are at home, if we had some home monitoring, whereas the big challenge is going to be is when do you trigger an alert? Obviously we don't want the healthcare team to be called every little time someone has a hiccup. So setting that threshold is going to be a big challenge. Now we've started to look a little bit at this by using smart games. And so we'll be doing this with a group in Surrey called Cognitia. And we're looking at things that can measure your reaction time, for example. So this is a simple game where you are pretending to be a photographer and an animal pops up and you're supposed to snap its picture. And really what we're assessing, of course, is your reaction time. And this is another thing where you go to the store and you've got some items and you have to make sure you buy all the right items. Again, what this is doing is assessing the working memory. And if we can do this in an engaging way, then we can serially track people over time and see whether or not there's been any deterioration that warrants further investigation. We have other apps that can assess your motor performance. We've also looking at eye movements. I won't spend a lot of time on this because we have a poster in the back, but we do know eye movements are abnormal in Parkinson's. We do know that abnormal eye movements are associated with motor deficits. And we know that in people without Parkinson's, the eye movements are trainable. So the big question is if we train eye movements, can we improve some of the symptoms? And that's a poster at the back that you'll be able to see. Now, the challenges, as I mentioned with all this, is we're going to drown in data. And we're going to drown in noisy, low-quality data. And so a lot of investment is going to have to be put towards analyzing these data. The Michael J. Fox Foundation has appreciated this, and that's why they have this, what's called a dream challenge, where they have noisy data and they've asked people to try and extract meaningful information out of it. So that's just their recognition of what's going to happen. And as I mentioned, once we're drowning in data, we have to look at ways. This is what Google and so on is doing. How do you, once you have mountains and mountains of data, how do you fuse it together to get a meaningful picture of someone? So, we can measure things like your cortical thickness, we can do PET imaging, we can do behavioral information, we can do genetic information, but how do we actually sum all that together to get a coherent picture of the individual so that they can be best managed? And, that's a very important part of this. In the medium term, of course, we have PET and MRI imaging. Again, Dr. Stossel and Dr. Sosi will talk about this. And I will mention that one of the things that we've noticed in the MRI, we've started to look at the white matter. We've taken a technique that was originally developed for another disease, MS, and applied it to Parkinson's. And we've already noticed that there are subtle changes in this, and we think this is quite exciting. And then over the long term, of course, we'll hear from the molecular biology perspective from Professor Farr.